Thank you very much. Thank you for having us. Good morning, everyone. I know it's early, so try to make the talk very simple, friendly, lots of emojis. Don't be frightened by a very long title, Sovereign Interoperable Privacy. Let's get started. So quickly about me, my name is Billy Rennekamp from Louisville, Kentucky, the home place of, yeah? Hell yeah. Home place of bluegrass music, thoroughbred racehorses, and bourbon whiskey. So if you'd rather talk about that today instead of cryptography or crypto, come find me. I'm the Cosmos Hub lead at Interchain, so I lead the development of the Cosmos Hub. Previously, I was developer relations at Tendermint, did a lot of work prior to that in the Ethereum space on bonding curves, NFTs, did web development, and a background in electronic art. So again, we have a chill out zone. Come talk to me about any of that. Independently, I have an NFT gallery called Folia.app and a generative NFT project called Clover's Network. But today I want to talk about the Cosmos philosophy and why it really makes sense for building especially privacy-suited blockchains. But what is the Cosmos philosophy? Oh, wow, we've got the Android emojis. This is going to be exciting. So Cosmos is all about sovereignty and interoperability. And I'll go into more detail about exactly what that means and why it really works. But before that, I thought I'd give a little bit of a tour of some of the other philosophies from other blockchains. So Bitcoin you can think of as in some ways doing well on the sovereignty front. They do one thing and they do one thing well. And so that means that they have sort of, everybody's sort of on board for the purpose of this blockchain. It's just meant to be a store of value. It's gold. What's missing here was the little emoji with the British Guard. Because as sort of like solely focused on one thing, they are quite insular. They don't really care about the rest of the world. They say, this is the only blockchain that matters, this is the only thing that matters. And so interoperability, bridging to other blockchains, interoperating was never really part of their goals. So they do sort of well on the sovereignty part. It's their blockchain doing their one thing, but they really fail on the interoperability aspect. Ethereum, they do a lot of things. They try to make everything happen at once, which is great. You've got like a stadium where you can all get together. And when you're all in the same space, it's really easy to interoperate. You have access to smart contracts from smart contracts, atomic transactions between them. But this doesn't really scale. I mean, you know the sort of disaster zone when you have a stadium that's filled with too many people, how bad it gets. And the other problem with that is that unless you're in the stadium, you don't really have access to the other people and the services that are happening there. And when you try to scale that, you get overcrowded block space. And the missing emoji here, of course, is a gas canister. That's sort of the fallout that what happens when you're all trying to do the same thing at the same time. Whereas Cosmos, we try to hit the sweet spot of sovereignty and interoperability. And quickly, I'll talk a bit more about sovereignty. So sovereignty means that you have sort of an application-specific blockchain. It does the one thing that you want it to do, and it does that really well. You're not sort of dictated by the other users on your blockchain who want different things from you. And Ethereum, of course, back in the Berlin hard fork last year, all of these Aragon smart contracts broke because they changed the hard coding gas costs for one of the transactions because it was just one user amongst many. And they thought, yeah, this change is going to be better for everybody, but if you're a small fish in this pond, you kind of get wrecked. Interoperability, of course, is when you have an application-specific blockchain, you don't have shared smart contract zone in which everybody sort of has immediate access to each other. And so you need to create a protocol, which we have as IBC, in order to talk to other blockchains. So this little diagram, you can sort of see Bitcoin kind of has sovereignty, lacks interoperability. Ethereum lacks a sovereignty. Everybody's trying to do their own thing, but they're using the same space. They do okay in interoperability as long as you're inside of their walled garden, whereas Cosmos presents and promotes sovereignty as well as interoperability. Why this matters for privacy. Sovereignty is a stand-in for privacy. When you have sovereignty, you can change your blockchain in any way that it needs to, and that's especially relevant when you want to introduce privacy to different levels of the stack. So you can think of the Cosmos SDK as this modular framework that's separated between the application layer, the consensus layer, and the networking layer. If you want to add privacy to the application layer, you're able to do all these sorts of fun things that we see from different projects talking today, like Penumbra, Anoma, Secret Network, and NIM. They're able to sort of design their blockchain to have the features that they need specifically. They can customize it, so it meets the needs of their application. It's application specific, it does just what they need. You can also add privacy to the consensus layer. So there's ongoing work at Osmosis to add encrypted mempool so that you can prevent minor extractable value. This is where you have the transactions themselves are encrypted until they're included in a block, and only then do they get decrypted. So you don't know what the other transactions are inside of the mempool. This sort of modularity allows you to make changes at each level of these stacks, so you can introduce this kind of customization. There's also networking, where NIM and Penumbra have different aspects of cloaking or interacting at the network level, adding cryptography, and Celestia doing, God, I just forgot the word, erasure encoding. Not exactly at the networking level, but relevant to that sort of aspect of the stack. So altogether, Cosmos is sovereignty plus interoperability. Sovereignty being a stand-in for privacy allows you the customization to sort of build your application-specific blockchain to your needs and your users' needs. So how does that look here? It's modular all the way down. Just a bit of an overview. How do we achieve this? The Cosmos SDK is the application framework where you can see the stand-in for the Cosmos Hub. It has a protocol between that and the networking level called ABCI. And so this is a separation between what your application does and how the consensus is achieved and the networking operates. And because all of these separations means that you can make changes at one without having to make changes at every single level. So it allows you to jump in just where you need to, as well as IBC. IBC, we have a talk later today as well. There's sort of a possible future development introducing zero-knowledge proofs at that level as well. So each of these pieces are sort of ripe for targeting and elaborating, extending, and adding different privacy capabilities. And then, so this is the way the world works right now. You can jump in and do any of these sorts of things. But what I'm really excited about coming next that offers another sort of interesting configuration is Interchain Security. So Interchain Security is basically a separation of concerns from the validation and block production of your network from the application layer. Interchain Security means that you can take a blockchain like the Cosmos Hub and use the same validator set there. And the way that this works is basically every blockchain, looking back to this set, uses ABCI to communicate with the consensus layer. ABCI says, hey, who's allowed to produce blocks on this network? Inside of the application state, typically you'll see proof of stake module that says, oh, I've got a bunch of stake representing these different validators. They're the ones who are allowed to produce blocks. That's great. But if you don't want to build your own validator set, you don't want to worry about that part of your application. Say your application is extremely focused on just one very specific thing, and you're like, OK, I don't really need a token for this, or hey, I don't really need to introduce this whole validation system or recruit all these people to operate it. You're able to use the same validator set of the Cosmos Hub, use the staking module of the Cosmos Hub that says these are the ones who are allowed to produce blocks. And instead of using ABCI to talk to your own state machine that says these are the validators, you use ABCI to talk to the Cosmos Hub's set of validators. They're the ones who are given permission to produce blocks on your blockchain, so your blockchain just does what it's supposed to do at the application layer. That's Interchain Security. That was kind of fast. Do we have any questions here? Please. Yep, exactly.
What if you had, so the follow-up question is, what if you had your own blockchain and you wanted to actually maybe not share default validators with the Cosmos Hub, but like have multiple instances of your own chain to share validators? Would that also be enabled more easily with this separation of instances? I mean, I don't know those plans the first time.
Yeah, actually, so that's...
Billy, can you repeat the question?
Yeah, so the question was restatement of basically Interchain Security, but the question was, if I have my own blockchain, can I have multiple instances of my own blockchain with the same validator set? Is that kind of...
Yeah, being able to have validators work on both instances of the chain.
Being able to have validators work on both instances of the chain. Yeah, so we like to say there's two ways to scale a blockchain. There's vertical scaling and there's horizontal scaling. Vertical scaling is where you basically make changes in order to increase the number of transactions per second. You know, there's all sorts of tricks, bells, whistles, and band-aids to sort of maximize the number of transactions per second that we've seen across the entire blockchain space. There is like a physical limit, you know, to how many transactions a single state machine would eventually be able to do, even with all of these improvements. And so at that point, we like to think that horizontal scaling is the way to go. And horizontal scaling is essentially taking one blockchain and just redeploying it. you now have 2 instances, so it can process twice as many transactions. However, traditionally, if you launch another blockchain, who's producing blocks on that network? You know, you need to start a whole new staking token. You have to raise value for that if you want it to have the same security. And so instead of having to rebuild that aspect of the blockchain, you can replicate the validator set with Interchain Security. And that's basically how we're approaching the Cosmos Hub right now. So a couple of the first projects launching with Interchain Security later this year are projects which could otherwise be deployed directly to the Cosmos Hub. Now, one nice aspect of that is now that you have 2 instances of these blockchains running, you know, you sort of double the capacity for the block space. But the other really nice thing about that is that it decreases the surface area of complexity and faults on the Cosmos Hub. So if the Cosmos Hub needs to be this super secure blockchain that's never stopping running, you know, atoms need to flow all day long, how do you add more and more features without introducing more risk of, hey, maybe there was a bug there, maybe we're going to have a chain fault? You push it off to a separate blockchain. So the Cosmos Hub, all it needs to do is just export the validator set over IBC to this other blockchain. And if that blockchain has a bug, it stops, maybe something bad happens, doesn't affect the Cosmos Hub. It's able to continue producing blocks, continue shipping, you know, this is the validator set. Once this other blockchain comes back online, it's able to get all the sort of updates and keep running. But it's sort of created fault tolerance around the sort of application state, which is a really nice feature, and exactly why we're sort of approaching it, because we do think the Cosmos Hub needs sort of the highest integrity of security, should not be introducing unreasonable risks, and pushing it out to interchain secured zones is a way to sort of be much more adventurous on the features that can go on the Cosmos Hub without introducing extra risks. And this same concept can apply to any other blockchain. It's a bit like multi-threading for a blockchain. You sort of are able to separate the concerns and maximize the throughput, as well as yeah, like I said, separate the concerns. Question from Will?
So one of the main reasons you would expect chains to continue to like launch with their own validator set as opposed to like inherit whichever one is the largest, like the Cosmos Hub?
Sometimes the validator set does more than producing blocks, and you know, I can imagine that offers a level of complexity that they might decide, oh, my validators need to be much more than just block producers. They also need to be X, Y, or Z. And when those concerns overlap really well, then I think it makes a lot of sense. Sometimes there's aspects of the token economics that really, you know, demand or make sense when you have an independent validator set. One aspect that I like that I think is going to become more visible is actually the separation of concerns for what the duty and the job of a validator is. So right now on Cosmos chains, the validators produce blocks, yes, but they're also governmental representatives. When you delegate stake to your validator, you sort of give them the ability to vote on your behalf. Now, we have liquid democracy, so if you ever disagree with what your validator is voting for, you can put in your own vote that goes against it. So you always have access to your own tokens to vote in part of the protocol. But generally, most people just let their validators represent them. And we've gotten a lot of feedback from validators that they actually feel conflicted about this. You know, they're top of their game producing blocks, running infrastructure, but that doesn't mean that they necessarily have a really well-informed decision or opinion about like the application that they're running, the DeFi protocol itself. You know, they don't know necessarily the parameters for the inflation, et cetera. You know, let them do the one thing that they're really good at, running infrastructure, and let the other people who are, you know, informed in the application perhaps be more present and active at the governance level. And when you have a separation of concerns with interchain security, you're able to sort of say, okay, Cosmos Hub validators, you're, you know, the longest validator set, you've been sort of the oldest, the best, you've made the trail, you've learned all the lessons. Like, do the thing you're really good at, produce blocks, but let's have a separate governance token on my interchain secured zone. And you're able to reproduce basically the same governance system, except for instead of being a block producer and a representative, it's just representatives. When you enable that, you're actually able to expand the set of validators on that consumer chain, is what we call the sort of chain that's consuming security, in order to have way more than, you know, 100, 200, 300, which is sort of the maximum set of validators we see in Cosmos chains today, because it doesn't have the same implications. You know, when you have massive, massive validator sets, you potentially have slower block times, there's more network congestion, but when their only job is to be governmental representatives, you know, it can be sets into the thousands or more. Any person can say, hey, you know what, I'm really active, I really understand what this project's trying to do, I'm going to register as a validator. You know, it's in quotes because they're no longer asked to produce blocks, they're just asked to produce governance votes. And hey, delegate to me, let me vote on your behalf, because you know that I'm spending every single day in the Discord, I'm spending every single day on crypto Twitter, and I'm really, really excited about doing this work. And what's kind of interesting is when you reproduce the governance system that we currently have, these purely elected individuals are able to charge a commission on the block rewards. You know, they actually have a really interesting way of earning money for being active and part of the validator set. You know, hey, let me charge 10% of every block reward because I'm going to do a great job making this network valuable. I'm going to make sure that we continue to sort of improve it in the right way. They can get the delegations, they can earn an income for this. And all they have to do is just care about the protocol. They don't have to care about producing blocks, because I think if you look around there, it's actually really hard to produce blocks. And, you know, we see protocols who are launching with thousands of validators or have goals of millions of validators. And there is sort of this question, like, can you expect millions of people to be able to run really high quality infrastructure? Because it's not nothing to produce blocks. So it's another sort of nice characteristic that comes out. But again, there are certainly lots of value in launching the traditional way. It's new technology. You know, I think everybody's always a little bit nervous about trying things out new, but I think we're going to see a nice sort of testing ground where those new ideas show their value. Any other questions? That went way faster than I thought. I'm really sorry. I didn't get... We're on time. Look at that. Amazing. Cool. Well, thanks very much. Look forward to the other talks today and all the other projects coming up.
Thank you. Oh, yeah, do you want to give this?